Okay, hi, my name is Jillian. I'm going to be doing some practice one-dimensional kinematics word problems. Okay, so you'll notice that I have three key equations up here, 1, 2, and 3. Okay, so I'm just going to go through the equations and talk about what the variables mean. Okay, so for the first one, VF is final velocity, and that is equal to initial velocity, which is denoted by the little I, and then you add the product of acceleration and time. Okay, so this is VF is equal to final velocity, VI is initial velocity, A is acceleration, and D is time. Moving on to the second one, XF is final position, and XI is initial position. Same with VI and T and A and T as it was in the other one. So this one is final position equals initial position plus initial velocity times time plus 1/2 of the acceleration times time squared. Okay, our third one has one new variable. It is D, and that has to do with final position and initial position. But VF, VI, and A all remain the same. So this one is final velocity squared minus initial velocity squared equals 2 times acceleration times displacement. Okay, so I'm going to do some practice word problems now. The first one we're going to do is, I'll read it to you. Okay. A jalopy travels on a long straight level road at 50 kilometers per hour and then speeds up to 90 kilometers per hour in 15 seconds. Calculate the jalopy's acceleration in meters per second. Okay, so we know that we need to find the velocities in meters per second, and as of right now, they are in kilometers per hour. So we need to fix that, which would be, oh, that's not even right. Okay, so if it's 50 kilometers per hour, and we need 1 hour over 60 seconds, and that'll give us kilometers per second. I'll pull out my handy dandy calculator when we'll need it later. This is 50 kilometers, 60 seconds, times 1 kilometer per, what is it, 1,000 meters. Okay, so if you're doing those calculations, you will get 50,000 divided by 60, which I'm doing on my calculator here. Oh, whoops, I did wrong. Okay, 50, 1, 2, 3 divided by 60. Okay, so you'll get about 833 meters per second. Okay, so that is the initial velocity, because that went from 50 kilometers per hour to 833 meters per second. So I'm just going to start creating a table right over here with all of my variables, because that makes it easy to solve. Okay, so I'm going to start with A, T, X, F, X, I, V, I, V, F. Okay, so right now we have just figured out VI, and that is 833 meters per second. Oh no, you can't see. I'll put VF on the top here. Okay, so 833 meters per second. And I'm going to do the same thing except with the other velocity, but that is 90. So I'm just going to change the 5 to a 9 here. I don't want to rewrite it. I'm lazy. Okay, equals 90. Okay, so what we'll end up getting is 90, 1, 2, 3 divided by 60. I'm again doing this on my calculator. And that gives us 1,500 meters per second. It's pretty fast.